Welcome to lesson 7.3, slopes of parallel and perpendicular lines. Now, before we get into today's lesson, like what you need to know, is I just want to redefine three words to you, and that's parallel lines, perpendicular lines, and skew lines, which you probably don't even know because I haven't said it yet. So let's go over these. Let's just do a quick reminder, okay? Parallel lines are lines that never touch. They'll just go on and on and on and on and on and on and on, and they'll never touch. So if you see these two lines right here, they are parallel. They go on forever without touching, okay? Now, you also have perpendicular lines. These are lines that intersect, and they intersect in a very specific way. They intersect at a 90-degree angle, all right, or a right angle. So perpendicular lines always make right angles. So whenever you see perpendicular lines, they make right angles with each other, okay? And then you have this thing called skew lines, all right? And skew lines, what is this? Skew lines are a bit different. Skew lines are any line that's not parallel or perpendicular. So these are lines that intersect that are neither parallel or perpendicular, okay? So it's two lines that are not parallel, meaning it's like they definitely touch, but they don't make right angles. So if you look here, if we had this example, right? These two lines are skewed because that's not a 90-degree angle. This is like 100 degrees. So if you have something that are intersecting, but are not 90-degree angles, that's skew lines, okay? So it's basically everything that's not parallel and perpendicular, all right? So those are the three definitions you need for today. Now, here's the thing that you got to know. This is the main points right now. We're going to be talking about the slopes of these different kinds of lines. Now, the slopes of parallel lines are always the same, all right? They are always exactly the same. Now, an example of this would be if you saw two lines that are parallel, the slopes would be, let's say, 3 halves and 3 halves. You see how these are exactly the same slope. The slopes have to be exactly the same. Now, if I give you an example like this, let's say I said M1 was 1/2 and M2 was -1/2. Are these two exactly the same? No, these are not parallel, because they have to be exactly the same, okay? So any slopes that are exactly the same, you know the slopes are parallel. So if you checked out the slope of these two lines, you'd actually see that they have the same exact slope. So slopes of parallel lines, they're the same. Slopes of perpendicular lines are what we call the negative reciprocal, all right? Now, we're going to break this down. Basically, all it is you flip it over and you change the sign. That's what the negative reciprocal is. So to give you an example of that, let's say I had these two slopes. Let's say I had 3/4 and -4/3. These two are what we call negative reciprocals. All right? So it's flipped over. See how these are flipped over? One's positive, one's negative. And that's really important. One has to be positive, and one has to be negative. Okay? So that's what negative reciprocals are. One's positive, one's negative, and they are flipped over. So that would give you perpendicular lines. And then the final one is what we call skew lines. Okay? And skew lines are anything not parallel or perpendicular. So if it's not parallel and it's not perpendicular, then they're skew. So let me give an example of that. A simple example would be this. Imagine if I gave you 3/4 and 4/3. This is exactly like our last example, right? But they're both positive. And since they're both positive, it's not parallel because they're not the same. They're not perpendicular because they're not negative reciprocals. So these would be skew. All right? It's not parallel, they're not perpendicular, they're skew. Other examples I can give you, let's say, you can keep that there, but let me just come up with another example. If I had 1/7 and 2/3. These are not parallel, they're not the same. They're not perpendicular because they're obviously not negative reciprocals, so these would also be skew. They're different, they're just different. They have no rhyme or reason to them, and that's that, okay? So those are the three things. Now, today's whole lesson, all you got to be able to do is look at the slope of two lines and tell me if they are parallel, perpendicular, neither. That's it. We're going to look at two slopes. You got to determine, put them in one of these categories. Are they parallel? Are they perpendicular? Or are they skew? All right, you got to look at the slopes and just figure that one out. So let's get into some example problems, okay? Now for the first one, it says determine whether the two lines below are parallel, perpendicular, skew, and justify your reasoning, right? So we're going to write a little bit there. Well, what you're going to do is this process. Let's look at the two lines that are given, and we're going to isolate the slopes, all right? So for the first one, we have y equals 1/3 x plus 2. The slope is 1/3. So you should write this. Right now I'm putting this here for you, but you should always write the first slope is 1/3. The second slope is y equals 1/3 x minus 3, and the slope here is 1/3. So if you look at these two slopes, they're the same. So we know they're parallel, okay? So let's write a conclusion. So the lines are parallel because the slopes are the same. And that's a good justification. Let's try the next one, okay? Now, here's what I'm going to say. For the first one, it says y equals negative 2x plus 1. If you ever see a whole number, like you do here, put a 1 underneath it. If you ever see whole numbers, you put a 1 underneath, okay? You'll find out why in a second. But just do that. If you ever see a whole number, put a 1 underneath. So our first slope is negative 2 over 1, negative 2 over 1. And our second slope is 1 over 2, all right? So we have negative 2 over 1 and 1 over 2. Now these two are negative reciprocals. And since they're negative reciprocals, they are perpendicular, okay? See how they're flipped over? One's positive. We got a positive here, and we got a negative here. One's positive, one negative, and they're reciprocals. So our answer here, the lines are perpendicular because the slopes are negative reciprocals. Done and done. And let's try this third problem right here, okay? Determine whether the two lines below are parallel, perpendicular, skew. Graph both lines to justify your reasoning, okay? So instead of writing a conclusion here, we're going to actually graph this to show that it is what our answer is. So first, we're going to isolate the two slopes. Slope 1 is 3 over 2. Slope 2 is 2 over 3. Now, if you look here, these are not parallel because they're not the same. They're not perpendicular because they're both positive. I'll even write that up here. Both positive, right? So they can't be perpendicular. So these are what we call skew, all right? Because they're neither parallel nor perpendicular. So the lines are skew because not parallel or perpendicular. Now, let's just check this by graphing. Now, a great thing about this is if you're ever confused, let's say you forget the rule real quick. You like blank out. You're like, wait, I don't know what happened. What's the rule again? You could always just graph the lines to check. So let's actually graph these two lines and see if they are in fact skew, okay? So the first one has a y-intercept of negative 2, and you go up 3, 1, 2, 3, over 2, up 3, over 2, okay? If we graph this line, it's going to look like this, okay? That's line 1. Now line 2 starts at 3, and this one goes up 2 over 3, up 2 over 3. And if you graph this line, it goes like this. Now, could you tell me that these two lines intersect to make 90-degree angles? No. So are they perpendicular? Nope. Are they parallel? Nope. So these are skew. This looks like a 150-degree angle, you know? So these are definitely not parallel or perpendicular. We have proven without a reasonable doubt what these are. All right, so let's look at 3 more problems that kind of represent what you're going to have to do on today's lesson, okay? You have to be able to look at two lines and determine if they're parallel, perpendicular, or skew. And these are what the lessons these look like. The lines represented by the equations 3x plus 6y equals 6 and y equals 2x minus 4 are parallel, perpendicular, skew. What you're going to do is the following. You're going to write equation 1, 3x plus 6y equals 6. And then we're going to write out equation 2. Okay? And that's y equals 2x minus 4. Now we need to know the two slopes. All right? So I'm going to put m1 equals and m2. You got to write this in yourself. You always want to isolate the slope at the end and compare them. Now let's figure out the slopes. Now, 1, we don't know because we have to solve for y first, right? This isn't in slope-intercept form. But number 2 is pretty easy. This is in slope-intercept form. It's already in slope-intercept form. So we could just see that the slope is 2. Okay, so we got our first slope. And like I said before, I forgot to do that even. You want to drop a 1 under that. So that's 2 over 1. Always drop a 1 under whole numbers. Now we'll find the next slope. All right, and you might remember this from the last lesson. We're going to solve. So I'm going to subtract 3x from both sides. All right, we'll bring down the 6y. 6y is equal to negative 3x plus 6. Divide everything by 6. And you get y is equal to negative 1/2 x plus 1. So we're going to isolate the slope. It's negative 1/2. We're going to put that over here. And so our two slopes are negative 1/2 and 2 over 1. These are negative reciprocals, so these are perpendicular. All right, so negative 1/2, 2 over 1. Those are negative reciprocals. So the lines are perpendicular because they are negative reciprocals. Okay. So that's it. You just write out your two equations, find the two slopes, write your conclusion. Okay, so let's try this again one more time. Now what I suggest is this. What if I were you is I would pause the video now, see if you could do this one on your own, and if you have figured it out, unpause the video, see if you got the same answer. Okay, so pause the video now and see if you got it right. Pause it now. Now. Okay, now that you're back, and hopefully you already paused it, we'll do these together. So we have equation 1 and we have equation 2. Okay? Equation 1 is 5x minus 15y is equal to 30. Equation 2 is y minus 3x equals 4. All right? Now remember, I do expect you guys to state equation 1 and equation 2 like I'm doing here, okay? Now both of these we have to find the slope for, so we got, you know what, I'll put the m's over here. So we got m1 and m2. We're going to compare them over here, okay? We got to get our two slopes. We can't answer it without the slopes. And neither of these are in slope-intercept form. So let's solve these out, okay? So we're going to subtract 5x. We bring down negative 15y is equal to negative 5x plus 30. Divide by negative 15. And we get y is equal to 1/3 x minus 2. And that is our first one. So slope number 1 is 1/3. Now let's do number 2, okay? For this one, all we have to do is add the 3x to the other side. All right? That would isolate the y, so we have y is equal to 3x plus 4. So our slope here is 3, but remember we drop a 1 under our whole numbers, so our slope is 3 over 1. So if you're looking at these two slopes, what do you think they are? Parallel, perpendicular, or neither? Are they parallel? No. Why? Because they're not the same. Are they perpendicular? No. They're both positive, so they're not negative reciprocals. They are reciprocals, but not negative. So that means by the process of elimination, these are skew. So our conclusion is the lines are skew because not or perpendicular. All right, and now for the last one. This one's a bit different. Let's read it together. Points A is 5,3 and point B is 7,6. They lie on AB. Point C is 6,4 and D is 9,0. They lie on CD. Determine if AB and CD are parallel, perpendicular, or skew. Now remember, to determine if something's parallel, perpendicular, or skew, you need the slopes. And is there a way that we can get the slope if we are given 2 points on a line? Is there? Have we figured that out? You're damn right we have. So what I'd like you to do is, once again, pause the video, see if you could solve it yourself, and then come back, okay? Pause the video now. Okay, I'm trusting that you paused the video. Not sure I believe you. Let's do it together. So we got line 1, we got line 2. All right? Our points on line 1 are A is 5, 3, and B is 7, 6. Okay? For line 2, it's C is 6, 4, and D is 9, 0. Now to get the slope, what are we going to use? That's right, the slope formula. So we're good math students, so we always write down our formulas. Okay. All right, and now we'll just plug in. So y2 is 6, y1 is 3. x2 is 7, x1 is 5. So when we do that, we get 3 over 2 as our first slope. All right, so m1, 3 over 2. m2, our y2 is 0, y1 is 4. x2 is 9, x1 is 6. So for this one, we get negative 4 over 3. And that is our slope for that one. So our slope is negative 4 over 3. We look at the two slopes. Are these parallel? No. They're not parallel because they're not the same. They're not perpendicular because these are not reciprocals, right? They're definitely not reciprocals, not perpendicular. So these are skew, okay? So that's how you answer these questions. That's it. Now, my advice to you is to kiss your mother, do the dishes, and then go downstairs and just pick up a little bit of candy, because moms love candy. I don't know if she'll like chocolate, maybe she likes Skittles, but just pick her up a little goodie, you know, just to show you love her. All right, that's it for this lesson. Peace.